Okay, the last one, we look at the RFID. Probably lots of people here heard about the RFID. It represents the radio frequency identification. You see the word identification? Yeah, again, it's used to identify a devices. That means if we have a devices attached with the RFID, it will be addressable. Okay, will be uniquely addressable. Okay, the first figure represents the basic operational principle of the RFID. Okay, you can see to the left we have a circular RFID tag. Basically, this is the small devices containing data. If we have sensors equipped, that means if we have sensors equipped with tags, then the sensors sensing data will be stored in the tags. Okay, to the right of the figure, we'll see circular antenna and reader. Basically, you can call it a reader. The reader will be transmitted the electromagnetic field, which is an EM wave containing energies, which is wireless signals through antennas to the tag. Okay, so this is electromagnetic fields based on the electrical and magnetic interactions. So the electron EM field received by the RFID tag will be converted into electronic energy. So based on this electronic energy, it makes the tags get energy to send the data out. So every time when the reader try to read the data of the tag, just emit signals. Once the tag receives the signals, then the data will be sent out. The energy will be basically provided by the reader. Okay, so that means the tag is basically no power. Okay, so this is circular RFID. Basically, this kind of operation is circular passive RFID, no power. If we have battery equipped with the RFID tag, that will be called active. The major difference between these two is the distance. So for RFID tag passive, the distance between the tag and the reader can only be 1 to 3 centimeters. But for active, it can be 10 meters, 30 meters, or even longer. Okay, this is the difference between RFIDs. Okay, this is basic operation. Okay, down below we have some examples. Okay, so you can see we have passive examples, and the passive readers we amplify. The last one here is something like a circuitry. You see lots of copper loops. It represents antenna. The reader's EM fields will be induced electricity powers based on this antenna on the tag. Okay, so the tag receives the EMF, the power, the signal's energy, convert to electricity, then get energy to trigger the circuit on the tag. The signal, the data can then be transmitted. And to the right is active one. Okay, we'll look at the system operations from the viewpoint of application. Okay, so you see we have basic RFID systems, which is tag and reader. Okay, on the right lower bottom of the figures. Here we see the readers gather data. It will send the data to the processing units. Here we call the central computer. Okay, then the data will be collected and through the network may be stored on specific devices. So we see the RFID, the sensing, and then we see the computing, and also we see the big data or even in the cloud. Okay, this is the whole system of the RFID. So we see the operation of RFID, and then we also look at it over the whole picture of the RFID applications. Okay, the next part we talk about the networking layer, which means how data can propagate it to the back end. Okay, so we call it data propagation in IoT. This visually talk about the communication or networking technologies. Since once we have a look at the technologies, in general, we have lots of representation symbols. So that's why we have, for instance, says technology equals to the standards. basically we can apply the wireless to major category. Wired so far include Ethernet and the recommendation standard 232. Wireless will be covered a lot. Okay, so for general wireless network, people talk about wireless, it means the Wi-Fi, which means wireless local area network or Wi-Fi direct, but we see the Wi-Fi a lot. And the next one is a public cellular network. This is basically is what we mean. The mobile communication is for long distance, include the 3G, 4G, and the future, the 5G. And the last one is called short distance, like Bluetooth, RFID, the example we just explained it, and Zigbee, Z-Wave, and so forth. Okay, so you will see the three technology here: Wi-Fi, mobile, and Bluetooth will be underlined. In the following three slides, we will experience. We make a brief summary of these three to look at bit detail about the difference between these three. The last one, we talk about the industrial applications. So we have industrial wireless sensor network. What is a wireless sensor network? Basically, we talk about networks, means lots of devices connect together. Sensor networks is dedicated for sensors connected together. Wireless means the connection will be in wireless formats, no wire connected. Industrial means it's dedicated, designed for industrial application for factory. Okay, so this is so-called wireless sensor network. We put one I, industrial wireless sensor network, or industrial IoT. Okay, so this is some standards. Basically, they are all wireless, like IEEE IO2.15.4, IEEE AO2.15.4E, and so forth. Okay, but we're not going to look at the detail about this one. Just mention, say, for IoT, we have two similar terms. One is the wireless sensor network. So in many cases, when we talk about the wireless sensor network, it's basically is the IoT already. Okay, another one is so-called cyber physical system, CPAs. Okay, this is the basic technology applied for Industry 4.0. Okay, but there will be out of the range of this course. So we just mentioned about a little bit of the WSN. So keep in mind, when we talk about the IoT, basically WSN and IoT will be the same in most cases. Okay, look at the first one, the Wi-Fi technology. Basically, this is the short distance area network. Means we have devices connected together within same building, okay, or among buildings, okay, within a few kilometers. This is what we mean the local area network. But this device basically communicates to each other in wireless through the antenna. This is so-called wireless local area network. But people like to use the term Wi-Fi fidelity. This is wireless fidelity. This is what we mean Wi-Fi. Okay, we just look at the latest technology or the standard. All of this the Wi-Fi technology will be standardized by the IEEE, as you heard about the IEEE, which is the abbreviation of Institute of Electrical and Electronics Engineer. Okay, that means Wi-Fi systems are all defined by IEEE. Okay, we look at three technology: 11.N, AO2 11.AC, and AO2 11.AD. If you have a circular access points equipped at your office or at your house, you will see they are all AEN, EEAC ready, or even EEAD. The difference is speed. Okay, so we only look at the first two. One is how fast the data can be transmitted under different standards or technologies. So look at the EEN, it will be 600 megabits per second. AC will be 3.2 gigabits, and EEAD will be up to 7 gigabits. So 7 gigabits per second, in this rate, we can propagate the high definition videos without compressions in original forms through the wireless. This is a very high speed. The coverage will be basically less than 100 meters. Of course, it depends on the strength of the emitting signals, the transmission power, which can be adjusted. And also it depends on the environment, since once you have a block furniture or walls will be blocked wireless signal a lot. Okay, so the coverage or the distance of the wireless signals basically is a references. 100 meters is basically theoretical values for your references. Okay, this is Wi-Fi technology.